Today we are going to learn another important concept as a part of Lean Six Sigma and minitab. Thank you so much for joining on time, and let's start learning of this. So today, the first topic that we are going to learn as a part of this six common mistakes in performing process capability analysis and solutions. So here we are going to understand what is the process capability, what is its importance, and then we will go into the details of what are the different tools and when we are going to perform these tools into the real life, like capability analysis specifically, then what are the common mistakes that working professionals are doing? And the most important part that how we can avoid these mistakes so that our results are the most effective results. That means we can take the actions in the correct directions. So that's the important part. And before to start the today's session, let me share the screen first. Yes. The first topic is what is SPC and its importance. At any point of time, if you're having any questions, please put that into the chat box. And as and when I will get the time, I will answer your questions. Don't worry, if we didn't get the time, I will answer all your questions at the end of this live streaming. Okay, so please don't worry about it. So let me share the screen. Yes. Can you see my screen? Just use the chat box to communicate. Yes, yes. Thank you so much. Thank you so much. So let's go into the first part. The first part is about what is the SPC, what is the statistical process control, and what's its importance. This is important to understand first what is SPC because as we are going to see the process capability, one of the most important part as a part of the statistical process control. And before going into the details, what are the mistakes we are doing? Just understand what is SPC. Statistical process control is an important tool as a part of Lean Six Sigma which uses the statistical techniques to analyze a process in order to monitor, control, and improve any kind of processes. What is the triangle that we can see here? Monitor, control, and improve. That means if you want to improve our processes, we need to control our process first. And if you want to control our process, we must be able to monitor our process. So if you can see that into the reverse direction, we cannot control any process unless we are not able to monitor that process effectively. That means we are again not able to improve that process if we are not able to control it. So monitoring, effective monitoring of the process performance is the first step. Then controlling the process is the second step. And the third one is an improvement into that process. So if you want to improve any process, it is very important that we must be monitor and we must be control that process. Only in that condition we can improve that process, right? So that's why statistical process control is very important. It is helping you to monitor the performance of your processes. If you are able to monitor, we can control and we can improve the process, right? So to do any kind of improvement into the process, the first step is we need to use the statistical process control. So that's the importance of this important technique. Now, do you have any questions onto this? Sriharsha, thank you so much joining on this live streaming. Facebook user, I cannot say what is the name, but thank you so much. Right? So once we understand what is SPC and why it is important, let's go to the second point, which is what are the tools and techniques as a part of this statistical process control. Now, if you see statistical process control, it mainly consists of two set of tools. The first one is a control chart, and again it consists of the wide variety of control charts, including control charts for the continuous data, attribute data, time weighted control chart. But in today's session, as our focus is not on the control chart, it's about what are the common mistakes that we are doing into the process capability. So we are sticking our focus only onto this capability analysis. Now, as a part of capability analysis, we can see there is again huge list of tools that we can use. First of all, if you want to learn the process capability analysis, we need to understand all the concepts and terms that are used in process capability analysis. Now, why I am explaining this to you, because this is again one of the common mistake. Once we go into the common mistake part, that again I will explain that in detail. But here, please understand, even if you are going to conduct the process capability analysis, the first step that we need to understand, what are the various process capability indices, what are the various terms and concepts that are used in process capability, right? So the first step is learn all the terms and concepts into that. Learn what are the best practices. Why? Because if you don't follow these best practices, it is resulting into the mistakes. Then we must know what are the types of variation, because if you are taking the actions when it is not required, again it is creating the more variation into your system. What are the types of data? Then what are the data distributions that you are having, and what is the correct distribution of your data? That means if you collect the data, then which distribution is best fit for your data? Again, why I'm telling this to you, because the selection of the correct capability analysis tool is depending on the data, that data you have collected. Now, what is mean by that? Let's say if you're having the continuous data, then you might be conducting this process capability for the single variable or the multiple variable. If you're conducting that for the single variable, we can use these tools. Like we can use the normal capability analysis, non-normal capability analysis, and also between and within capability analysis. If our data is single with a single variable and it's a continuous data. If your data consists of the multiple variables, then we can use the normal and non-normal capability analysis depending on the type of data. Now, whether our data is following the normal distribution or it is not following the normal distribution, for that purpose, again, we need to use the multiple tools. That is a part of this capability analysis. If you're having the attribute data, then we need to use the either binomial or Poisson capability analysis. So this is the proper selection of the tools. Now there is an advanced concept which comes into the as a part of this capability analysis, which talks about capability six pack. Why it is important? Because if you are using this capability six pack analysis, it is helping you to reduce the mistakes. That means it will check the data considerations for analysis, and at the same time it will also help you to perform this capability analysis, right? So this is just an introduction part before to go to the mistakes, okay? Because whatever the part that I have explained to you, that will help you to understand the solution part. That's why I have explained that in detail, okay? So let's say if you're having any questions till the point. Great. So the next is, let's go into the details now. Now we have understood what is the SPC and why it is important. We have understood again what are the tools and techniques that are as a part of statistical process control that we can use into the real life. Now, the today's main topic is what are the 6 common mistakes that working professionals or the quality professionals or the people are doing while performing the process capability, and what are the solutions for them, right? So let's go into the detail and let's understand one by one all these mistakes. Now, the first mistake is when we are calculating the process capability, you might have seen that the people are only talking about the CP and CPK. Only relying on CP and CPK is the first mistake. Only relying on CP and CPK to say the process is capable or not. And when we are saying that, when we are considering the CP and CPK, especially in the case of assembly processes, that means if you are calculating the process performance for the child parts, and after that, if you are going to include that parts into the assembly process, then there is another important capability indices that also we need to look for. It is CPM. Now, if you are just relying on CP and CPK, it is not giving you the clear idea, right? That's why it is again very important. Don't rely only on CP and CPK, because it will not give you the correct output, correct results, correct interpretation. Now, what will be the result of this? you might take the wrong directions or wrong actions based on that. Okay, so this is the problem. This is a mistake that people are doing, that only relying on CP and CPK. Now, what is the solution for this? Solution is see all the capability indices, right? See, look at for CP, CPK, PP, PPK, also look for CPM, right? That's a very important, and also look for the PPM. Now, another important thing that we also need to look for the graphical results. Review capability analysis graph before conclusion. Now, why it is important? Let's say if I am saying that CPK is 2.3, okay, and or let's say talking about the CPK, in that case, on which direction we need to take the actions, right? So for that purpose, we need to understand distribution data, and that will be clearly explained by the graph, right? Let's say if you're having the CPK is 0.9, that means on which part of the graph we need to take the actions. Either we need to take the action on the lower control limit, lower specification limit, or upper specification limit. To decide that, we need to understand our distribution, and for that purpose, the graphical results are going to help us. That's why just don't rely on CP and CPK. Consider all the capability indices, and at the same time, please also look for the graphical results. So that's the first mistake and the solution for this. Now, what is the second mistake that working professionals or people are doing? Don't check the type of data before use of tools. I had seen that working professionals or the people are directly collecting the data and using the normal capability and analysis to perform this capability analysis. And whatever the results they are getting, people are taking the actions based on that. This is a wrong practice, right? So this is the second mistake. Now, what is the solution for this? We need to understand what kind of distribution our data is following, whether our data is following the normal distribution or non-normal distribution. If our data is not following the normal distribution, let's say our data is following the non-normal distribution, then what kind of non-normal distribution? Either it is a variable distribution or exponential distribution, what kind of distribution our data is following? We need to check that. Now, again, why? Because I have explained during the tools and techniques in SPC as a part of second section of today's topic that based on the type of data, we need to select the different capability analysis options. If our data is fitting the normal distribution, we need to use the normal capability analysis. If our data is not following the normal distribution, then we need to check for which distribution that our data is good fit. And according to that, we need to select the non-normal distribution for that distribution, non-normal capability analysis for that distribution. So this is the second mistake and solution for this. This is very important, and please make a note of it, because these are the common mistakes that I had seen the professionals are doing into their daily life. The third mistake is again very important, that no involvement of subject matter expertise in interpretation of the results and creating an action plan. Again, if you are not involving the subject matter expertise into the capability and analysis, that means the interpretation of the results can go wrong. So again, while you are going to interpret the results and when you are going to convert that interpretation into the action plan, please involve the subject matter expertise. So the solution for this, involve the subject matter expertise. Now, what is the meaning of subject matter expertise? The people who are having the knowledge about that process, that product or service or information in which area you are going to perform this process capability analysis must be involved. Must be involved during planning of the process capability analysis, performing it, and also during the interpretation of the results, deciding the action plan, and real life implementation as well, right? So this is the third mistake and the solution for that. Now, what is the fourth mistake? This is, now let's go into the more statistical part of it. What is the fourth mistake? Inadequate sample size. I had seen that people are just collecting the data for, let's say, 20 samples, 25 samples, and doing the capability analysis based on that, right? This is again the wrong practice. This is the common mistake again. So we must have at least 100 data points, 100 sample size. That means if you are going to collect the data in subgroup and the subgroup size is 4, you must have 25 data points. In that case, if you are having the 25 data points and if you are performing the process capability analysis, it's fine. Or let's say if you are having the subgroup size of 3, then in that situation, you must have the sample size of 35. If you see all together, you must have at least 100 number of total data points. If you are going to collect the data in subgroup, then it should be divided by that subgroup size. So this is again very important because to represent the population for which you are going to perform this process capability analysis, you must have the adequate sample size. So this is the fourth mistake and this is the solution for this. Now the fifth mistake that I had seen, that measurement system capability is not checked. Now to collect the data for the process capability analysis, you are using some measurement instrument. That can be in some cases, it can be the completely automatic device, or it can be semi-automatic, or it can be total manual process. But irrespective of what is the mode of your measurement system, that measurement system must be capable. If that measurement system is not capable, means what? Whatever the data that you are going to collect with that measurement system is not reliable. It's not accurate. Now, if you are going to draw the conclusion based on this data, you might be in danger. That means you can say the process capable process as a it is not capable, or not capable process as a capable, because your measurement system is not capable, right? That's why it's very important that whatever the measurement system that we are using for data collection to perform the capability analysis must be capable. In other words, I can say the capability analysis must be done with the data collected through capable measurement instrument, capable measurement system. This is the fifth common mistake, and this is the solution for it. Now, the last mistake that I had seen, that people are performing the process capability analysis as a part of sequence, but the process must be stable and in control for data collection. That means we must calculate the process capability only when our data is stable and in control. If our process is not under control, if you can remember the meaning or the importance of statistical process control, which I explained during the introduction part, the triangle: monitor, control, and improve. That means if the process is not in control, and if you are going to calculate the capability of that process, it is of no use, because your process can give the different capability as a part of time, as a function of time. Let's say if you are going to calculate the process capability analysis into the first shift, it can say that your process is capable. In second shift, it can say your process is not capable. In third shift, again, it can say your process is capable. Now, why it is so much of difference? Because your process is not in control, right? So to perform the process capability analysis is the primary stage or primary step is your process must be stable and in control, right? And to avoid that, we need to check the stability and whether your process is in control or not. If you are going to perform the capability analysis six pack, this assumption is going to be checked, or this mistake is getting avoided when we are going to use the process capability six pack, right? So calculated capability analysis would be correct only if the process is stable and in control during data collection. So these are the six common mistakes that people are doing while performing this process capability analysis, right? So this is the very important part of today's session. Do you have any questions on this? Please put that into the chat box. Great. Thank you so much. Now, the last part of today's session is how we can learn the process capability analysis easily and effectively with practical examples, right? So I have explained you what is the importance of statistical process control, what are the tools as a part of this, then what are the tools, what are the mistakes that people are doing, and how we can avoid that mistakes while the real life implementation. Now, how we can learn the process capability. Now, if you want to learn the process capability in detail, then we need to follow this 10-step approach. Although some part of that approach I have already explained during the mentioning of what are the tools and techniques as a part of SPC, but let me explain that in a systematic or in a stepwise approach. The first step is You need to understand all the concepts in capability and analysis. As we are discussing about the capability analysis, the first step is understand all the concepts or tools into this capability analysis. That means what is the meaning of CP, CPK, PP, PPK, CPM? What is the importance of the graphical analysis into that, right? So everything we need to understand. What is the specification limit? What's the control limits? How the control limits or how the this CP and CPK is getting calculated. So everything we need to understand. Second, understand the application of the concept. Then, as we are going to use this tool into the real life, depending on the type of data, depending on the mode of data collection, we can see there are different tools of capability analysis that we need to use. Like if you are having the continuous data, different capability analysis tools. Attribute data, different types of capability analysis tools. Again, if your data is following the normal distribution, capability analysis, non-normal capability, and if your data is non-normal, then detect this distribution is best for feed your data, and again use the non-normal capability analysis for that, right? So there are different situations, and we need to understand in which situation which tool we need to apply. Now, once we select that why we are going to use that tool, then again we need to understand the other data requirements for that tool. Like what are the best data collection practices, right? Then what should be the adequate sample size? So everything we need to understand. That is nothing but the data requirement for that tool. The next one is learn the procedure to follow during application. Now, when we are using the procedure, when you are using this or when you are going to perform this capability analysis, the process that we or carrying out this process, again we need to select the different options, which option we need to select into which situation. So everything we need to understand as a part of this. Then take an example and use the tool. Now if you are having the access to the minitab, you can use the minitab, or even if you don't have the access to the minitab, you can also use the excel or any other statistical tools to perform this capability analysis. Now, as a part of my system, I have explained how we can perform this process capability analysis using Minitab, Excel, as well as Sigma Excel. So you will get the entire details there. Then interpret the results after application of the tool. That's very important. And don't forget to involve the subject matter expertise and also the expert from the statistics or from the Lean Six Sigma knowledge or from the quality knowledge, the person who is having the knowledge about the process capability, so that you can calibrate your understanding of the results with that person. Seventh is convert it into actions, implement that actions into the real life, of course with the help of subject matter expertise. Check the effectiveness of actions with the tools and practice it regularly. So this is the 10-step approach that we need to follow if you want to learn process capability analysis easily and effectively. And if you want to learn that by following this 10-step approach, learning all the tools in capability analysis, here is a link that you can visit here, vijaysabe.co/capability, and you can learn this capability analysis in the most effective and practical way with the help of practical examples. Okay, so this is the process. Now let's come back to the section, comment section. Do you have any questions for me? Please ask any questions that you are having related to this capability analysis. What are the mistakes that we had done and how we can avoid that? Anything that you want to add, that is also welcome. Okay, so this is the program that I was talking about, capability analysis, with examples in Minitab, Excel, and Sigma Excel. If you want to learn this in detail, so this is the link where you can visit. You can also get this link into the description section, and you can visit, you can learn what are the topics you are getting as a part of this. This will, again, you are getting with the help of supporting data that you can use to perform all these capability analysis into the Microsoft Excel, Minitab, and Sigma Excel as well. And you will also get the lifetime handholding support with that. That means if you are having any questions, you can directly connect to me and you can also get the answers to your questions. If you are getting to enroll into this program, then please don't use this coupon code so that you can get the 10% off as a part of my mission. Use this code as a mission 100K. Okay, so this is all about the statistical process control, specifically related to the capability analysis and what are the common mistakes that people are doing and how we can avoid that into the real life. Any questions, any comments, please put that into the comment section. If no questions, then thank you so much for your valuable time. And I'm sure with this live streaming, you got the idea about what are the mistakes and how we can avoid them while performing the process capability analysis into the real life. Thank you so much and see you next time.